The HBT-2000P is a great welder in our opinion. We've already rated it a 4 in our initial review. In this video we're going to show you how to upgrade it to what we would consider a 5-star. To do that we have two upgrades. The first is dealing with the WP26 torch, which is stiff and heavy. This Euro style torch has amperage controls that we really don't care for. We're going to go over what's needed to install a hybrid CK-17 flex head torch. How the current switch, 5-pin connector, and main board are wired to that. Plus, gotchas that bit us. The second, fixing the loose gas connector on the front panel. And that's common in this unit. We've seen other people have mentioned it. Let's take a quick look at the actual unit.
On the bottom is the gas line. And above it is the 5-pin connector, and there's the positive ground, and then the negative for the electrode on the other side. That is a DIN 50 pin. It's not a hollow. The gas doesn't flow through it. The gas flows through the separate line. And you have your 5-point pin here, you can see, and that attaches to this very heavy because this is a really thick cable for sending the power up. The gas line is thin, the electrical line is thin, but this power line is really heavy. It's because it's a 200 amp torch. This is a WP26, and this torch has the multiple controls on it, which I don't like. I don't like the up and down amps on here. The gas flow is nice. I've used that once in a while, but sometimes that's a pain too because it initiates an arc if you hit it. And then there's the trigger switch. That's the only thing I really want. This torch, again, it's so big and bulky. It's made for, welding up to 200 amps, which is great for, but for all the welding I'm doing with tubing, this is way too much.
So let's begin by opening up the unit and taking a look inside.
Removed. You loosen the back, one on each side, two on the bottom. That allows that to move back. Then you remove the screws around the outside of the cover and the two on the handle. Then you can tilt the entire cover up and out, so it comes out of here. And you can see there's connections are pretty massive for the electric. It's great, as expected for 200 amp. And here's the little nut in here that was loose that made this wiggle. So now I can tighten that down and get this to be nice and tight the way it should be.
To allow the correct mapping of the pins and wires to our new CK-17 torch, we want to take a look at the 5-pin connector while we have the unit open. And it seems it's a 2-pin plus 3-pin setup.
You can see the back of the 5-pin. You can see that there's red, blue, and a black that come up to one switch plug in. One switch plug in here, and then there's a red and a black that go to another connector right below it, a 2-pin connector below it. So there's a 2-pin and a 3-pin connector. I'll have to follow to see which connections they go to on the back of this, on the back of that 5-pin. The red and the black is probably on-off switch, the trigger switch, and the red, black, and the blue is probably the raise and lower voltage.
Now we know what color wires go where on the board from the 5-pin up front. So the first two go to a connector labeled P3, and the last three go to a connector labeled P6 on the board. And you can always refer back to this if needed. Now we need to figure out what the wiring is in the WP-26 torch from the switch to the 5-pin. 5-pin on our torch cable. And if you take off the little clamp on the end here, you then can unscrew the metal part from the plastic part. And when you do that, you can see what your wiring is. Pin 5 is white. Pin 4 is red, but it's jumping over to pin 2 as well. And pin 3 is brown. On pin 2, there's a small black wire. You can't see it because it's behind there, right there, maybe. That's soldered on here. So the black is going to pin 2 with the jumper going over to pin 4. Pin 1 is blue and gray. And then the last piece of the puzzle is the wiring inside the torch from the 5-pin to the switch. And we're going to need to open up the torch to take a look at that. It has 6 small Phillips head screws that you can take out. And once you do that, then the handle itself will just come apart. Revealing the power connection, which is here. You can see that huge wire coming in. There's a big connector because this is a 200 amp. And then here's your little gas line coming in to the tube inside of there. And here is the switch and the wires corresponding, the gray, the white, the blue, and like take this out, and here's you can see the gray, brown, white, black, and then blue. And you can pop this off as well, and then you see the little sealed switch making it waterproof. Now that we have the switch out, we need to break it down to see where the wires go, what the tracing is, how the switches match up. The waterproofing cover, just peel around the edges and it'll come right off. And inside, here's your micro switches. Okay, so this is on off, this is lower voltage, this is raised voltage, this is gas. And now I can actually follow the traced pins to see where they match up on here, and then I know the coloring by looking at this. I can tell what is what. Survey says now we have all the color wiring mapped up to all the switches. So we're going to start at the bottom and call the black wire trace 1, then it's blue, white, brown, gray, moving up on the switch. And following the tracing on the switchboard itself, we see that the black is basically becoming a common for all. The blue goes to the high frequency on and off 2T, 4T switch. And the white goes to decrease amperage switch. The brown goes to increase amperage switch. And the gray is the test flow switch. And they're all using the same common of black. Having this information lets us do the final color mapping from the torch switch and the micro switches on it to the main board connectors P3 and P6. More importantly, that allows us to do all the function mapping from the torch micro switches to the connectors at the end of the torch and then inside the machine itself, yielding this, which we only need the trigger, the high frequency T2, T4, because that's all we're going to use on our new torch. But for the future, we know how to increase and decrease the amperage and what all the other pins are. It's time to start building our light, flexible TIG torch, starting with a simple on-off 2T, 4T trigger. On our torch, from the multi-faceted one to a simple on-off toggle switch. 2T, 4T, and or if we're holding it down and keeping the torch ignited. We got Eastwoods because it comes completely with the switch and the 5-pin. But can't be used. These switches are just on off, so there's probably only, yep, 2 wires. So I'll use this switch, and I have all the wire connected, but we'll connect it to a new 5-pin that fits ours. A momentary switch. There's no negative or positive that you have to worry about. It's on off, so wiring it won't matter. I guess that's why they didn't worry about the color coding either, the blue and the brown, light brown. When you press this, it just need to do to convert this switch is to unsolder the blue and brown wires from this 5-pin so I can put it into a 5-pin that will work. In order to unscrew the black from the housing, you have to take this little Phillips screw out first. That holds it together. Wires from the Eastwood onto my connector. And what I did first was I heated up each one of these and put a drop of solder in there, had the solder flowing. Then I took the wire and placed it on top of the solder that was now on the connector. That usually works faster. These wires already had solder in them from the Eastwoods. Then I took digital multimeter and measured between here and inside, and it was 4.3, and did it on the other side, and then I did the same thing between here and the end of where the wires are, and it was the same reading. So good electrical flow. So these are okay. I can close these up. Now that the new torch switch is done, we just need to build the rest of the torch. But ran into a lot of issues we weren't expecting. You're going to want to see all this. Convert from the torch that comes with this, the WP. You've got 3 connections: the main power, the gas line, and the 5-pin. And more on that. The gas line is going to become an issue. But unfortunately, the DINS 50 became an issue. Wasn't expecting that. It says it's a DK-35-50. So we ordered a DK-35-50. This has a fitting for gas because we're converting to a CK. However, the real problem is that while they're both called DK-3550s, this one doesn't fit out of the box. And the new one is longer than this. You can see the difference. See how much taller it is and how much wider that pin is. This will go in so far, but then you can't turn it. And that's because of this extra area. So once we get rid of that, this thicker pin may actually work, but we have to do this first. I made quick work of cutting off the amount that I need to cut off just using a hacksaw. And it fits in nice now, but this pin is still not turning. So next thing I'm going to do is I've marked it, the extra thickness. I started from this end to make sure it was starting at the right spot, and now I want it to end at the right spot. So I'll just file away that green area. See how that works. To correct size, or size it'll go on. And one of the things I noticed was that it's the overall length. got was the CK-17-12.RSF.FX. It's a 12.5 foot, one piece, flexible, 150 amp torch. It comes assembled up to the rear gas, and we got this from HTP America, USAWell.com. Good price, great reputation. And what you do is you push the hose through the rubber insulator, and then you screw this in the back of the piece we just made, of the piece we just ground down, and we'll tighten this up onto this and then push it into here. We just have to line up there's grooves in this, two grooves in this that assure that the gas fitting goes through. So we just match it up with the grooves in there, and that will line it up with this hole for the gas fitting. Push the rubber on, and gas holes lined up. This is all done except for we have to put this little gas fitting on here. This is a solid end. It's not like a lot of the torches where the gas flows through the machine and into the hose. On the Hzxvogen, the gas is a separate line coming in, and this is how you get around it. You have to get this kind of a fitting. Is to fasten the gas line into the connector. Rubber cover here, the elbow. You can see that there's a nut that you can use to tighten it in, and you see this nice copper piece and a good crimp, so it looks like it's well made right there anyway. Millimeter on this to tighten it down. Now I just push the cover back on, and we have a finished unit. Now the torch per se is complete. So how does the old torch compare? It's 4.25 pounds. It takes up, you can see, almost all of the tray. Very stiff. This is large and stiff. CK, you can see it actually takes up a little bit less room. It's very, very flexible. There's only this small hose, and then it'll be the wire coming down. And the weight is 2.48 pounds. Let's do a simple compare. Here's our new torch with the trigger switch on it. For now, I've just got 2 zip ties, and the third one down here, and then some little ones here. I think I may build a sock or something for this later on, but right now I just want to do the comparison. Here you can see the old versus the new. Size. You can see the thickness and how you have to hold this. This I can do with a nice little pencil. Easier to grip. The flexibility, of course, versus, and then last but not least would be the connectors. Old system, it's hook up the gas line, hook up the 5-pin, and hook up the DINs. To hook up this, I have 3 connections. A 5-pin, but it's only really using 2. The gas connection and the DINs. Here's a final cost breakdown. The CK-17-FX torch with hose was $119.95. The DINS DKJ-3550 connector was $16.80. The Eastwood switch 5-pin was $21.31, and the female 16mm 5-pin connector for it was $6.99. So the total final cost for this hybrid torch is $165.05. The second half of the upgrade is to fix the loose connector on the front, but that's metamorphosized now that we have the 5/8 18 connector coming from the new hose. Portion on this, to tighten this up, you've got to hold this. That's 17 millimeter, 11/16, and the 5-pin above it, I actually, I'll show you in a second. The nut, to tighten up the gas line, I undid the nut on the back of the 5-pin. That allowed me to push it through, and then I just pushed the wires out. That gave me room to hold a wrench coming straight down and going onto that, and that is a 12 millimeter. So what you need to do is spin the hose clockwise, put the wrench on, and then turn this clockwise to tighten that nut. Now, they don't leave you, there's no extra line on this hose. I mean, it's tight fit, so that's why you have to do it that way. I wasn't going to unclamp this, and I don't think I want to try and change this fitting. So all the changes I'm going to make, other than tightening up so that's nice and tight now, I'm going to do on this side of the machine, outside of the machine. We have the gas connector in the unit all tightened up. Unit's all closed up. We have our new CK-17 flexible torch all done. Good to go, right? Nada. One more big gotcha. The second half of the gotcha with the torch conversion. We stayed with the standard fitting and did that on the front on purpose. Standard torches, CKs and most others, have a 5/8 18 thread that pushes the little nipple and holds it in place. You could swap it to a 5/8 18, but then you have to get the connector on the inside to work as well. And we didn't want to do that. So now we have to convert from this fitting to the 5/8 and still allow to use the old WP torch with this fitting. How do we do that? The right type of fitting might exist, but we searched on all of the websites for welding supplies and fittings and hoses, and we searched on Amazon, on eBay, on various pipe fitting companies. We went through a hardware store, almost every single little shelf box they had, and we couldn't come up with what we needed. Instead of wasting more time, we came up with what we think is a usable solution. Usable, but not perfect. Millimeter we could get was straight. It didn't have a flare in it or an inverted flare. But the 12x10 definitely fits on, so that's the right size. That's the size it is. Now we can put a compression fitting in between this and this to get that to seal. However, the 1/2" 20, this is an inverted flare, also fits on. It's looser, because it's not exactly right, but it has the inverted flare which will seal against here. Okay, so these are two possible solutions for fittings that will fit the machine. Now for two options using those fittings. First option is to combine several fittings to get to the final size we need, which is a 5/8 18 with a flare inside. Both the 12 millimeter by 1 and the 1/2 inch 20 have 1/4 inch MPT adapters. This allows using 1/4 inch fittings, a coupling on here, 1/4 inch fittings to go from this to the 5/8. Either the 12mm by 1 or the 1/2 inch 20. Fitting stock, so we can use the WP-26, or with the adapter and couplings and another adapter we can use the CK-17 with the 5/8 18. The second option, instead of going with this coupling and to a 5/8, we can go from the either the 12mm or the 1/2 inch 20 with the 1/4 inch MPTs to 1/4 inch NPT quick disconnect and put this on here. Quick disconnect and a 1/4 inch to 5/8. Then whenever we want, we just connect to the machine or not. If we want to use the WP-26, we take this off. Most of the time I'm going to be using this. I like this option because I'm not going to always want to have the torch attached if I want to move the unit or if I want to put the torch away. This is a quick way to do it and a way to easily use the WP-26 if I want to. Of course, the most important thing is, does it work? Well, here you can see we have our valve opened up and the ball is down all the way at the bottom. There's no leaking we can hear of here. There's no leaking on the machine at this end. It's all connected here with our new 5-pin that's a 2-pin, our quick disconnect, and our power lead. On. There's power to the solenoid, but it's still not leaking or giving gas out. However, if I tap the trigger, it's working quite nicely. What? What, you want to know if it welds? Okay, everything's hooked up. We use Teflon tape on everything. Argon's on. I don't hear any leaks. So, let's give it a shot. Looks like it does. Welds very nicely. I wasn't trying to do a good weld, I just wanted to see if it would weld. And I loved actually the arc. It gave me a beautiful arc. So now I just have to get used to it. But, the setup works.